Welcome to the Fast Mode podcast series. I'm Tara Nil, and with me today is Andrew Della Torre, Group Vice President of Technology, Oracle Communications. Oracle is a cloud technology company that provides organizations around the world with computing infrastructure and software to help them innovate, unlock efficiencies, and become more effective. Andrew is responsible for making strategic decisions that increase the overall competitive position of Oracle Communications and for defining direction for the best-in-class products and solutions that help customers compete in a rapidly evolving technology landscape. He also leads the technical sales, business development, and acquisitions teams for the business unit. Andrew joins us today as part of our exclusive editorial segment on generative AI for network management. Welcome, Andrew. Great to have you on today's episode.
Thank you, Tara. It's really good to be here and all your listeners, so I really appreciate the invite and the chance to speak with you.
Awesome. Okay, to start, what are autonomous operations in telecoms and why are they important?
Okay, so when we're thinking about what we consider autonomous operations to be, we're really thinking about networks that have the ability to self-monitor, to self-optimize, and to self-heal with minimal, may I even say, if any, sort of manual intervention. When we're really trying to kind of describe those as well, we like to reference the ETSI standards, the European Telecommunication Standards Institute, who've done a lot of work around network automation and categorizing these. And they actually have 4 defined levels of automation, whereby the ultimate level of level 4 is really when networks are able to adapt autonomously to changing conditions. And that's kind of like the ultimate goal. So we use that as something of a measure and a yardstick as we categorize this. So in terms of sort of the importance of that, there are actually, for me, 2 really key drivers as to why we should pursue this. The first one is kind of the more conventional and more discussed one, which is around the area of network operational improvements. So your ability to kind of reduce manual troubleshooting, improving your service uptime. You can lower, obviously, your operational costs through that and improve the overall efficiency of your network. And, you can drive enhanced customer experience, which is super important by taking out those service disruptions. But there is really a second driver as well as to why this is important, which is maybe not so much discussed, and it's the fact that this is really a critical lever for what I call the business transformation journey to unlocking new revenues for the service providers, right? And so as the kind of industry is moving its networks more towards sort of increasingly digital interactions with their sort of existing consumer customer base, this whole concept of real-time network provisioning and interactions with the network in real time becomes super important. But even beyond that consumer, we're increasingly seeing a repositioning of the use of these networks for mission critical applications in industry verticals. And, the operational improvements I spoke about, the kind of network reliability enhancements, that real-time provisioning capability, this is all super critical when your new customer is a digital business application and not a consumer anymore.
And where do CSPs and especially mobile operators stand today in terms of automation?
Yeah, I mean, if I go back to the kind of ETSI, level models that I spoke about before, it's kind of widely reported that most telecom networks are at sort of either level 2 or level 3, which means they have the ability to have partial automation, but it's still with human oversight. Now, I will just say one thing. In my experience, a lot of these surveys and these assessments are actually done based on the operator's own view, and they can be slightly optimistic, to say the least. So, sometimes I think it's not quite as advanced as maybe they make out. And, if I refer specifically to one recent survey, which was actually done by Omdia, in that survey, 55% of the CSPs actually reported that they still rely on manual intervention for their network operations. And only 29% actually claimed to have a kind of true state of network automation, which again I think is probably on the optimistic side of things. Now, when we work with our customers, what we've actually observed is there's actually quite a few common barriers to actually adopting network automation, which might explain this landscape a little better. There are certainly some key gaps we see in even starting the automation journey, and there are several well-trodden areas where automation is kind of a well-understood ability to try and apply these use cases. One is network planning, but we've seen a relatively slow adoption of AI-driven resource allocation models inside of the network planning space. A second one is service optimization. But the interesting thing about service optimization is it actually requires real-time analytics in order to work with full efficiency. And part of the problem there is getting the compute and the analytics engines that are capable of doing that at volume. And in a kind of telco environment where we're still really quite wedded to the on-prem sort of infrastructure solutions, getting access to those really powerful capabilities that you see in public cloud, of course, is not really there. A third one is around the area of troubleshooting, but again, what we're seeing is a lot of service providers are still really in the reactive mode in that space, instead of moving to sort of proactive and prevention. Now, if I look across at some of the barriers around sort of the bigger aspiration, actually moving towards full automation, couple of limiting issues here. Number one, still very fragmented data sources across the telcos. They have data repositories for their network, they have data repositories for their IT, they have data repositories for their back office. Everything is kind of quite disjointed and difficult to do real good data crunching and insights around. Similarly, there's still a lot of legacy infrastructure inside of those networks, which aren't AI ready. It's very difficult to integrate AI solutions into them. And finally, this is very real, there's the aspect around the security and compliance concerns. And so, moving to AI-driven decision making kind of has to be really carefully monitored to ensure that you stay within the right remit, of the sort of enforcements that are placed around them on their license conditions and that kind of stuff. So, it's kind of my view of where I see the market today and why I think it's there.
So you mentioned, how, automation and AI-driven automation specifically works in areas like network planning and then service optimization, and then troubleshooting, security, and compliance. Now, how effective is AI in predicting and preventing network failures?
Yeah, maybe I can answer that by way of an actual example. So we actually did an internal study of our own, based on our own customer support issues that we respond to and we look after through our maintenance programs. And one interesting data point we uncovered is that we found that effectively 53% of the network disruptions that we were observing were actually coming down to specifically signaling failures. Now, we were able to drive that down even further, whereby when we kind of analysed the root causes underneath those, we found that 30% was coming down to, inter-network function failure, so the communications between different network functions. 8% was coming from configuration errors. And then there was around 2% which was coming from sort of connectivity issues at the sort of layer one level. Now, the reason I share that detail is because knowing this actually has given us the ability to get a real head start in how we can actually define the core algorithms around these solutions, or the tuning of the models, depending on what kind of technology we're losing inside of the solution. So, we're now in a position where we can actually deliver AI-driven solutions through those insights that can actually cover a huge part of what we already see as being the major network challenges. And so, it's really based around AI as a vehicle to do predictive analytics, so being able to kind of detect those trends early and see the signs before failures occur. The second thing is being able to actually catch those anomalies in real time if you can't actually predict them. And so, your ability to constantly monitor all of the network parameters to do that. And this is where then the application of various sort of machine learning models, like the long short-term memory or other types of recurrent neural network models, becomes really powerful, because those can bring in the ability to use historical data that actually can drive the right insights from that, and that kind of example takes you to a place where you're instantly able to reduce network downtime because you can predict these things and get to the problems before they occur. But our analysis even sort of revealed to us that even if you get to the point where an outage happens, these kind of solutions can probably cut the mean time to resolution by maybe something like 15 hours per incident, which is not insignificant.
And are you already seeing early use cases for generative AI as well in this aspect?
Yeah, very much so. I mean, the interesting thing with generative AI, of course, is it's the topic of the moment, and
Yes,
everybody's
exactly.
sort of hot on it.
Yes.
And I think there's a lot of interest in the market in terms of how you could use generative AI. And right now, where we see a lot of the focus is more on what I would call the assistive use cases. It's something we might come back to in the conversation, but one of the interesting, sort of implications of generative AI specifically, it's a technology that's inherently designed to guess if it actually can't definitively decide what the right answer is.
Yes.
And that does introduce a degree of risk, right? And so
Exactly.
whether you choose to use that kind of model in a mission critical closed loop application, that's where we're seeing probably a few question marks in the industry. But the idea of, hey, this is a great technology to help us debug a problem and to give, operator assistance as to what a way to resolve it is, that's kind of the areas where we're seeing the interest.
And I guess that would leverage on the quality of data that goes into training of these models, right?
Absolutely, yeah. And this is another dilemma that the industry faces in terms of its affinity to try and preserve on-prem infrastructure versus public cloud, because the accumulation and the processing of these massive volumes of data requires a lot of compute. And at the same time, even in the very biggest networks, you only get one singular view of data that you can train the models with. So I do think that the industry is going to have to maybe consider its approach to public cloud and be more, embracing of that if they really want to get all the benefits from these technologies.
Wow, great. Now, let's talk about Oracle. What is Oracle's AIOps enablement framework, and how does it work?
Okay, so the framework that we have it's basically designed to help us embed AI-driven automation into 5G core networks. That's its main function, right? So when we talk about what that framework really is and the application of that framework, it actually results in us having a number of kind of key components or levers across the Oracle products and solutions that effectively then deliver the desired outcome. So the first one of those is a strict adherence to having fully cloud native functions. And so all of our 5G solutions were actually built from the ground up fully cloud native. We didn't repurpose any legacy code or do any containerization. They're full microservices architectures. Now that's really important because it's the foundational ability to access all of the automation and the tooling from the cloud native environments that gives you the ability to drive dynamic adjustments and automation, right? The second aspect for us was that, we created a product called Data Director. And I mentioned earlier, this kind of data fragmentation is a big problem. But similarly, the task of data aggregation is not insignificant. And so our Data Director product is specifically designed to be an aggregation capability. We can filter data, we can pre-process it, we can do all of that in real time, and we can do that across multiple data sources. This isn't something that's unique to Oracle. So a really important part of this is how to bring all the data together so that you can feed it into the model. Then we have, I suppose, what you would call the engine of this, which is the network analytics suite that we have, and that's where we have the AI models. That's where we have the models that can actually create the actionable insights. And we wrap this in an overall automation strategy. And so we're applying GitOps practices, microservices-based network functions to enable us to do this very rapid and easy deployment and replication of network functions, which can kind of unlock the power of self-healing networks and all of that kind of stuff. So, that's kind of the way that the framework ultimately sort of hits the road and what we have to build in order to effectively adhere to that and achieve the outcome we want. Now, to kind of wrap that up, what we sort of end up with is a solution that kind of does three things. The first thing it does is we use the AI engines to analyze network performance, network information in real time from all of these data sets that we collect in. The second thing it does is it generates the insights that are necessary for maybe fault detection or even preventative recommendations, for maintenance interventions or whatever. And then finally, it's leveraging all these automation tools to be able to then execute on those insights in an automated way.
Okay, so talking about these AI models, right? Do you see that? Is there a lot of fine tuning that takes place at different operators, or do you use a common model?
It can be a little bit of both. We have some customers who seem quite comfortable to take what I might call pre-prepared generic models. Of course, the job of tuning those models never stops. And so once they're implemented, the network, fine tuning is what I would call business as usual, right? But there are also customers out there who actually are more in favor of having a more customizable solution from the very beginning, right? And there could be different reasons for that. They may have some very particular use cases that they're trying to deliver and have a very precise view of how they want the models to apply to those use cases. Or it could be that, there's a general perception that it gives them a degree of flexibility outside of the more standardized approach. So, a bit of a mix in the industry in terms of what we see.
And can you share some real-world AIOps use cases for CSPs and mobile operators, maybe in 5G?
Yeah, no, I can. Obviously, I gave an example a minute ago for the other question. But let's do another two. I'd reiterate that pretty much everything that we've been developing sort of follows that same sort of three-step approach, right? Which is using that AI engine to do real-time network analysis, generating the insights, and then driving the automation. But, maybe two examples I can use here. One is around real-time network function capacity optimization. So in this particular use case, our AI models are effectively monitoring all of the network traffic and resource usage in real time. This enables them to make real-time decisions on the need to either scale up or scale down the network capabilities, on demand. Which of course ultimately is giving you the outcome of giving you a highly optimized infrastructure compute consumption, whilst making sure that you are never out of horsepower. You always have the performance and the capacity that you need. So, that's one, quite simple to understand use case, I think. There's another one that is kind of centric around the signaling, and I mentioned earlier that this is an area where we see a lot of pain in networks. So one use case that we've also developed is around using the signaling control point as a kind of hub. Now, the signaling control point, or SCP, in a 5G network connects to everything. It is effectively the data router for all the signaling traffic. That gives it a unique perspective in that it actually sees all of the signaling traffic in the entire network. So what we've done there is we've infused AI models into that to be able to analyze all of that traffic. We're looking for error rates, transaction failures, response time delays, all of those kind of things. And effectively, the models provide a health ranking for the network functions around that network. And that health ranking basically allows us to configure the SCP to route away from the network functions with poor health, which of course is ultimately going to give you, reduction in network congestion, less service outages, all of these things. So that's another example of something real that we've been working on. And, I will kind of double click on that word real I just used, because we are actually working these use cases in the field at the moment with, some of our big tier one customers in North America. So, this is real trial, not white paper stuff.
All right. Okay. Fantastic. So how does Oracle's AIOps strategy compare to your competitors?
Yeah, I mean, if you look at the typical competitors in this space, so the likes of maybe IBM, Infosys, Accenture, they have a very different focus to us, because they're taking an approach where they're building much more generalized AI capabilities, where they then effectively go into different use cases, even completely different segments and different markets. And they use customization to be able to tune those generic models to be able to fulfill whatever they're doing. So it's a very generalized approach so that they can get, wide coverage on the adoption of AI, not just at a comms level, but at, a complete industry level. As Oracle Communications, that's not where we are. Our focus is specifically on telecom. And so we've chosen to build solutions that are, centric around 5G and our telecom products, and they're not designed to be generalized to go out and do something with, a construction engineering company or a utilities company or whatever. And, there's a couple of other ways in which that sort of differentiation and that focus on network and 5G sets us aside. That the first one is that we've embedded AI into the network functions themselves, right? Okay. And of course, that's not something that the other competitors that I named a few minutes ago can do because they don't build 5G network functions. So that's not an avenue that's open to them. So we use our AI capabilities, we use the embedding of those actually natively into the network functions and all of the cloud native automations to effectively create a sort of solution level AIOps wrapper. And that works at a network level. And that means it's kind of ready to deploy, which means you don't really need a lot of customization to actually bring it up. Now, I will probably finish this by saying that doesn't mean, though, that there isn't a place in the AI ecosystem for those other players. And, there's a couple of main places where we see, them coming to bear and where they're very viable. The first one is the one we spoke about a while ago, which is we do see a number of network operators who want to lean very heavily into custom solutions, right? And, we're very much around trying to make it easy and pre-packaged and pre-prepared. The other players are much more open to, hey, we can build the model to do whatever you want. So sometimes, telcos lean into them because that's the direction they want to go in. The second one is that very often to get maximum value from AI, it isn't always just a network-centric story. It has to integrate into existing machine learning environments that are in other parts of their infrastructure estate or other parts of their business. And this is where those other players obviously can bring to bear the ability to do, system-wide integration across multiple systems. So, we're kind of frenemies from that perspective. I mean, we do our piece, they've got their piece, no hate there.
All right, amazing. So I can see that how the ecosystem is made up, and having niche or very customized solutions versus players who actually cater for few other sectors as well comes to play in this I would say fast growing area. So to wrap things up, what's the roadmap for AIOps, and what's the future of predictive intelligence in 5G?
Oh, okay. You want me to get my crystal ball out now? So
yes, exactly.
let's see.
We are taking notes, though. Yeah, taking notes for our stories for the rest of the year.
Maybe you bring me back in a year and see if my predictions were correct, right? So
I believe they will. They will.
There you go. I think if I look across the period ahead of us, what we've observed last year, throughout 2024, and what I certainly believe we'll continue to observe in 2025, is that there are certain key areas where there's definite traction, right, of uptake of these kind of solutions, and one of them is predictive fault detection and the associated kind of automated operations that sit behind that. One of the other things we see as being definitely active right now is proof of concept trials for kind of more complete AI-driven automation. So definitely there's interest in the market and there's a lot of trials being done. If I kind of go a little further out, maybe 2026, 2027, I do think we're going to start to see the increased adoption of specifically machine learning models in the space of network traffic monitoring. This is another area where I see a lot of interest. And once again, it's the adoption of doing that network traffic monitoring, bringing in the associated automated options optimizations behind, whether that's to, improve your load balancing capabilities or your capacity expansion. So, that kind of area of use case is something. I think in that same period, I'm expecting to see the first adoption of AI-powered real-time decision-making. Now, it's not so clear to me right now exactly which use cases, but I do think that we'll see, that kind of being applied in these timeframes. And certainly the continued and more mainstream deployment of self-optimization in the 5G network space. And here we go really long term, like 2030 and beyond. Look, the art of the possible. I mean, autonomous networks augmented by AI, completely, credible, completely possible. Generative AI we spoke about earlier, I think, we're going to see in these time frames a lot of adoption of that into the use cases for which it's really applicable. But I guess I would finish my prediction on one caution here, which is I think there's still very much a question mark in the industry around the adoption of what I would call true zero touch, right? And, the power of this technology honestly is undisputed, but handing over the keys to an entire network, it's quite a bold step, right?
Yeah. It is indeed.
And I kind of am a little cautious to see how far telcos are willing to go on this journey. But they'll have a lot of it, that I can guarantee.
Yes. And they're already talking about agentic AI. So I guess, people are gearing up in a big, big way towards this. But
yes.
All right. Okay. So that brings us to the end of the session. Thank you, Andrew, for sharing these brilliant insights on automation, AIOps, and Oracle's role in this space.
It's been a pleasure, Tara. Thank you so much for the time, and I hope the listeners enjoyed.
I'm sure they did. And to everyone tuning in, thank you guys for listening. If you want to learn more, visit www.oracle.com and follow us for more insights and updates as we continue to uncover the latest in technology and telecommunications. Bye-bye and see you again.